Single-page applications are dead. This might sound like an exaggerated statement, but I dare you to look around at the front-end space in 2022. First of all, meta framework solutions such as Next.js, SvelteKit or Solid Start are pushing forward the idea of isomorphic code, which, in short, is code that can reliably run on the client and on the server. As a quick side note, meta frameworks are a set of UI libraries, policies, and best practices bundled together in one big opinionated solution. The end goal of this approach is to provide a stable, scalable, and developer-friendly solution for any type of front-end app. Second of all, concepts such as the islands architecture gained a lot of momentum in the past year. Frameworks such as Fresh.js or Astro are popularizing this new way of serving interactive UI to the client, and the results speak for themselves. After all, who would have guessed that HTML-first apps, which lazily load JavaScript only on demand, would perform better than dumping hundreds of kilobytes of JavaScript to the client and then leaving all that rendering in the hands of the browser. Finally, the last 10 years of front-end development gave us the opportunity to learn and come up with more appropriate solutions for the modern web. I'm thinking here of Qwik.js, a fairly new solution which completely rethinks the way web apps are built, sent and rendered on the client by introducing groundbreaking concepts such as resumability. Before discussing in detail what are some of the more modern alternatives, let's see what are the main pitfalls of client-side rendering. I should probably preface this by acknowledging the fact that, of course, single-page applications have their use cases and are a viable solution in some scenarios. So how does a single-page application work after all? Well, first you need to choose a front-end library. Let's say you use something lightweight like Solid.js or Preact and not something heavy like React. On top of the core UI library, you'd also add some other utilities such as a router solution and probably some sort of state manager. Then, on top of all that, you'll write your application. Finally, using a bundler such as Webpack or Vite, you'll get a resulting JS file or multiple chunks if your app is well architectured. At this point, you are ready to serve your app to users, and the process should be familiar. The browser makes an HTTP call and gets back an HTML page where two things are of interest: a link to a JavaScript file containing all those things I mentioned earlier, and an empty element in the document body where the app will be mounted. Note that this HTML page doesn't really contain anything meaningful for a user or a search engine. At this point, users will still see a blank page in their browser. Next, the JavaScript file is downloaded from the server, and the script will be evaluated line by line by the engine. Once this process is done, the web app will be created and mounted in the DOM, events will be linked, and the users will finally be able to see and interact with your app. If you think that this is a lot of work for a browser, you are right. This is especially true by today's standards, where time to interactive metrics and SEO strategies are really important. If you are working on some enterprise internal tool or some sort of back-office admin where loading performance and search engines are of little interest, SPAs are the perfect tool for you. However, most of the time, this is not the case. Therefore, the community had to come up with some alternatives, and the release of Solid Start gives us the perfect opportunity to look into some of them. On their main page, the Solid team mentions multiple ways of rendering your app as one of their main strategies. So let's look at them one by one. We can skip over client-side rendering since we already talked about it. These are the single-page applications with their well-known pros and cons. Let's look then at server-side rendering. For a long time, this was the main alternative to address the pitfalls of SPAs. In the end, you'll see that this still is a flawed mechanism compared to the islands architecture, for instance, but let's not get ahead of ourselves. Compared to client-side rendering, there are two additional steps happening in the server-side rendering flow. First, your UI components will be rendered on the server, and the resulting HTML is sent to the client. This means that instead of an empty HTML shell and a blank page, the user will be able to directly see your app UI, which produces a fast first contentful paint. Then, a process called hydration is triggered. Server-rendered components are just plain HTML with no event handlers or interactions linked to them. So the internal server response will look like your app, but that is just static content which isn't interactive. The time period that the user sees non-interactive UI on the screen is also known as the uncanny valley. Although users may think that they can interact with the website, there are no handlers attached to the components yet. To solve this, once the JavaScript file is loaded, processed, and executed, your web app is built in memory again, and the event handlers are declared and linked to your DOM elements. This is the hydration process, and once it is completed, your users will be able to use your app normally. For large apps, this process can be time-consuming, so techniques such as progressive hydration or selective hydration were introduced. Patterns.dev does a great job explaining these concepts in detail while outlining the exact steps taken to improve the hydration performance and the time to interactive metrics. You are probably identifying a pattern here. The amount of time and effort spent on making modern web apps more performant might actually exceed the time spent on building the actual app. This is why frameworks such as Astro or Qwik perform so much better and are gaining so much traction. They were able to identify pitfalls in the current architecture and build more performant solutions from the ground up. While we discuss performance, the server-side rendering has yet another addition to reduce the time to interactive wait time: streaming. As the name suggests, streaming implies chunks of HTML that are streamed from the node server to the client as they are generated. The last rendering option provided by Solid Start is static site generation, or in short SSG. If you are not familiar with it, static site generation is a technique popularized by tools such as Gatsby or Hugo that creates HTML pages from templates or components and a given content source. So with this approach, the resulting HTML pages are computed in a build step, while your layouts and components are evaluated and computed on the server. This process is also known as pre-rendering. One caveat here is that all your routes must be known ahead of time, so dynamic routing has some limitations, and the SSG approach will not work for all scenarios. Think of an app that allows you to navigate through a list of movies stored in a database. If your database contains hundreds of movies, pre-rendering so many HTML pages might not be a good idea, and server-side rendering might be a better option here. Also, I want to underline that the word static in static site generation doesn't mean that your whole site needs to be static. Interactivity and behavior can still be sprinkled in using hydration. I hope that you don't have a headache by now and that this video gave you an idea about the blood, sweat and tears that goes into making your app perform better. Make sure to subscribe to this channel if you want to stay on top of all the moving pieces in the dev world, and please consider liking this video to help it get noticed by the algorithm. Thank you for watching.